So in the last class, we have seen the coordinate systems and the small volume element, the motion of an object in space. When it is represented, first of all, you have to fix the position of the object in space, for which coordinate systems are very helpful. And there are three types of coordinate systems. They are Cartesian coordinate system, spherical polar coordinate system, and a cylindrical polar coordinate system. In the case of Cartesian coordinate system, the position of an object in space is defined by three distances from the origin. One distance along x-axis, another distance along y-axis, and another distance along z-axis. The three mutually perpendicular axes. The intersecting point of all these axes is the origin 0, 0, 0. So when a body is moving along any one of these axes, then the motion is defined as the change in the length. It is a small length element. Suppose if that body is moving with respect to two axes, a motion which can be resolved into two components in two axes, then the motion can be defined as a small area element, because dx dot dy or dy dot dz or dx dot dz. If the body is moving a diagonal motion, and the motion is seen in all the three directions, then it is dx dot dy dot dz, which is a small volume element d tau. And the d tau is expressed in spherical polar coordinate system and the cylindrical polar coordinate system, and we have seen all of them. And we just started discussing the dynamical variables. Now I'm going to present the rest of the dynamical variables. The dynamical variables, first dynamical variable is time. So whenever you discuss the dynamical variable, you have to be very clear about the dimension and the unit. So the last class we just stopped here. Force is a dynamical variable. Force is mass times acceleration. So its dimension is even we can see from the beginning itself, so that we are a bit ahead of our syllabus. Therefore, we can go a little bit slow. The linear momentum, I've already explained what momentum is. Linear momentum is mass times velocity. So velocity is the rate of change of a position. Suppose a body is moving. What is its position at 0 time? And what is its position after 1 second? What is its position after another second? This is called the rate of change of position. If the body is not subjected to an acceleration, then that dx by dt will be a constant value. That is the velocity. Suppose I say the particle is moving at the rate of 10 meter per second. In the first second, it would have traveled 10 meter. In the second second, it would have traveled 20 meter, 30 meter, 40 meter, and so on. Therefore, the distance traveled in 1 second will remain 10 meter all along the travel, whatever may be the time taken, whatever may be the distance the particle travels, that will remain the constant. Suppose if acceleration is acting on the body, in the first second that may travel 10 meter, in the second it may travel 20 meter. In such a case, the acceleration is a 10 meter per second square. So it is the momentum mass multiplied by velocity, where velocity is a rate of a change of a position with respect to time. So it can be defined as mx dot. If you put one dot, that means that that particular variable is differentiated with respect to time once. You take the angular momentum. Angular momentum is for any rigid body. And I have already been informed that the ceiling fan or a table fan is an example for a body having angular momentum, a rotating body. In the case of angular momentum, we cannot speak of any velocity because it is not moving anywhere. It is in its own place and the body is rotating about its axis. And this rotation can be defined as d theta by t, that is the rate of a change of angle with the time. So rate of change of angle means if a body is stationary and if you want to make the body have a linear motion, you have to push the body, and that object shows a resistance to move. And when you are pushing, you are slowly increasing your force. And until a particular value of a force is reached, the body is not moving. So that is what is the maximum resistance that is shown by the body to move, that is called inertia. Inertia is a resistance to move. Inertia is a resistance to move. But when you think of rotational body, which exhibits angular motion, in such cases, you cannot think of any inertia. You have to turn the body. You have to give force to make the body turn. Actually, the turning about an axis is not at all related to the resistance to move, the inertia. Therefore, here it is called the moment of inertia I. So you should understand what is the difference between inertia and the moment of inertia. The moment of inertia I, which is equivalent to the mass in the case of linear motion. So mass in linear motion is equated to the moment of inertia in angular motion, where the velocity in linear motion is equated to the omega angular velocity in angular motion. Therefore, I can write the angular momentum as I omega, that is moment of inertia multiplied by angular velocity, which is equal to mvr. What is this r? Suppose this is the acting point and the body is moving here. There is a small radius. The angular motion will complete a circle. Now this radius multiplied by this velocity, that is v into r. Suppose if the radius is too large, then the angular motion can be considered a linear motion because the angle of a curvature will almost flat. Therefore, this mass, see, the moment of inertia will become a mass if you are able to know the radius of the curvature. So radius of the curvature, mvr, and hence you are getting the dimension mass length square. Why this length square? The velocity has one length per time and the radius has another length. Therefore, length per time into length, you are getting L square per time. So this is the dimension of angular momentum. Similarly, you can write the unit also kilogram meter square per second. Kilogram meter square per second, which is not written in this slide, and you can write down. It is kilogram meter square per second. What is acceleration? Acceleration is rate of change of velocity. Rate of change of velocity. Therefore, the dimension is L t power minus 2 and the unit is meter per second square. So acceleration can be written as dv by dt, which is equal to v dot. dv by dt equal to v dot. Dot means differentiated with respect to time once. But v itself is a differentiation. Velocity is rate of change of position. Hence, it can be expanded as d by dt of dx by dt. That is equal to d square x by dt square, which is equal to x double dot. Double dot means differentiated twice with respect to time. And the next dynamical variable is force. Force is mass times acceleration. When mass increases, force increases. When acceleration increases, force increases. Look at the difference. Mass multiplied by velocity is momentum. Mass multiplied by acceleration is force. Hence, I can write it is the rate of change of momentum. Look here. When you differentiate momentum with respect to time, you are differentiating momentum with respect to time. P is nothing but mv. Therefore, it is d by dt of mv. M does not change with the time. Hence, m can be taken out. So, dv by dt, which is equal to mv dot. Or I can write it is mx double dot. Or simply I can write it is p dot. So, when momentum is differentiated with respect to time once, you are getting the force. So, force is mass times acceleration. And the dimension of force is mlt power minus 2. And the unit for force is a kilogram meter per second square. So units and dimensions you should be very clear, because when you are going to do the numerical problems in quantum mechanics, you have to be very careful about the unit conversions. Not only in quantum mechanics, whatever may be the numerical problem asked, maybe in kinetics, maybe in any other things, and any part of the chemistry, if you are going to solve the numerical problem, the unit conversions ought to be given more attention. Otherwise, the entire numerical problem will be wrong. So the next slide, conservation. You should understand what is conservation before going to the conservation laws. Conservation is anything which is constant with the time. Conservative force or linear momentum is conserved. Conservation of linear momentum or conservation of angular momentum or conservation of energy. Conservation means something does not change with time. When time goes on, the value, the quantity remains the same. It is called conservation. So conservative force is the negative gradient of a potential energy, which depends upon, I think some slide is changed. No, it is, 8, 9. Okay, right. Only upon the position of the object, and it does not change with the time. It is called the conservative force. Why I'm explaining this? A force is not only mass multiplied by acceleration, it is also the negative differentiation of potential energy. Negative differentiation of potential energy is also force, which is the conservative force, means which depends only upon the position of the object and it does not change with the time. As the time goes on, the force remains the constant. When a body is falling down, actually there is a decrease in the potential, and that decrease in the potential is actually causing the acceleration. Acceleration due to gravity means there is a decrease in the potential, but the acceleration right from the beginning till the end, it remains the same as 9.8 meter per second square. Therefore, velocity may increase, but acceleration remains constant, and hence the force remains constant because the force is equal to mass times acceleration. If acceleration itself changes, then the force will change. If a body is falling from a very long distance, what is acting on that body? What force is working on that body to make it fall down? Is the conservative force. Why it is called a conservative force? The force remains a constant with the time. As the time goes on, the force is not going to change. The body will be falling down. Its velocity will go on increasing. Its momentum will go on increasing, but rate of change of momentum will be a constant. It won't change. Or the rate of change of velocity will be a constant, or the acceleration which is acting on the body will be a constant. It is not going to change. That is why the force which remains the same with the time, which does not change with the time, is called a conservative force. And that the conservative force is a negative differential of the potential energy with the time. So the next dynamical variable, I suppose you understand the conservative force. The next dynamical variable is a torque. Torque is called the twisting force. Twisting force is torque. And you may be having the experience of closing or opening a nut or a bolt using a spanner. See, in a spanner, suppose this is the position of the bolt, and you want to turn to tighten the bolt, and this is the spanner, and you provide a force here. Is a force, the force acting place. Actually, the work is done here to tighten the nut. So if the length is more, that is why for bigger nuts you are using lengthier spanners. Or you can simply say, think like this: a cycle pedal. When you are pedaling a cycle, you are giving the force on the pedal, but which is acting on the axis. If the pedal is lengthier, then your pedaling will be smoother. If the pedal is shorter, then your pedaling will be tighter. This is something like twisting force, or a steering wheel. When you turn the car steering wheel, actually the force is given on the ring, but which is conveyed through the connecting that radial shaft, and which is working on the axis of the wheel. This is called a twisting force. Twisting force. So twisting force is called a torque. Suppose if you take your RC book of your motorcycle or your car, there it is clearly mentioned what is the torque generated by the engine. The maximum torque generated by the engine at a particular RPM. When the engine rotates at these many rotations per minute speed, what is the torque generated? Today, you take the RC book and see what is the torque of your vehicle. It is a torque. And you see that the torque is very clearly mentioned in the unit Newton meter. Even in your car or in your bike, it is mentioned in Newton meter. It is torque. So the dimension is a force multiplied by the radius. What is force? Force is mass times acceleration. Actually, this acceleration is what is acting at this point, this acceleration into distance, Therefore, it becomes a kilogram meter per second square. This part, kilogram meter, what is acceleration? Meter per second square into another meter for distance. Therefore, the unit becomes kilogram meter square per second square. And also the dimension becomes m L square t power minus 1. Actually, this can be rearranged like this: L square m t power minus 2. So, what is a twisting force? A force that tends to cause rotation. It is the twisting force. And it can also be given the unit joule per radian. What is a joule? Joule is work done. What is the joule per radian? Is also another unit for the twisting force. You should always remember here the small rearrangement is done. Actually, the dimension is m L square t power minus 2, but it has given a different dimension L square m t power minus 2 because in order to make the difference between angular momentum and the torque. See, look at the angular momentum. It is also m L square. What happened? M L square t power minus 1. But here it is m L square t power minus 2. Therefore, no problem. It's a t power minus 2. Okay. Look here. Twisting force. Work. Work is, sorry, I've wrongly said. In order to differentiate it from the work, work is a force multiplied by distance. You should understand this. What is the force acting on a body and what is the distance to which the body is moved? I am pushing a body and the body is moved to a distance. So here the force into distance, and here is also force into distance, but this distance is the radius. Force is acting in this direction. This is the radius. But this distance is something like pushing a stone. Suppose a big stone is there. You want to push the stone, and what is the force given on the stone, and what is the distance it has moved? That is called the work done. Here the dimension is m L square t power minus 2. And the unit is the same. Kilogram meter per second square into meter. Therefore, in order to make the difference between the twisting force and the work, the L square is brought here. So the dimension is L square m t power minus 2. Here it is m L square t power minus 2. Unit for work is joule. 1 joule is 1 Newton per meter. If 1 Newton force is acting, 1 Newton force is acting on a body and the body is moved to a distance of 1 meter, then the work done is 1 joule. Next, energy. What is energy? Energy is capacity to do the work. Energy is a capacity to do the work. So what is work? Force into distance. What is force? Kilogram meter per second square into meter. So this is kilogram meter square per second square. So dimension m L square t power minus 2. Look here, energy, work, all are similar. So L square m t power minus 2 is torque. So this is energy. Energy is the capacity to do the work. What is action? Action is, it is an attribute of dynamics of a physical system. That is energy multiplied by time. It is called action. What is energy? Energy is m L square t power minus 2. You multiply this with the time, you will be getting m L square t power minus 1. It is called constant of action. Planck's constant is a constant of action. Later on, I will derive how the Planck's constant is called constant of action. See, Planck's constant, look here, this is the Planck's constant. E is equal to mc square, this is Einstein's mass energy relation. E is equal to h nu, which is Planck's radiation law. You know one thing, nu is frequency and c is velocity of light. C is equal to nu lambda. This one equation you should always remember. C is equal to nu lambda. Frequency multiplied by wavelength will give you the velocity of the wave. So C is equal to nu lambda. So when you equate mc square and h nu, you can write h nu is equal to mc square, but h is equal to mc square by nu. Nu c is equal to nu lambda means nu is equal to c by lambda. If you substitute the value of c by lambda in the place of nu, you will be getting mc lambda. What is m? Mass kilogram. What is c? Velocity meter per second. What is lambda? Again meter. If you multiply these factors, the h has the dimension m l square t minus 1. Therefore, the Planck's constant has the same dimension as that of angular momentum. It has the same dimension as that of angular momentum. And coming back to the dynamical variables, what is power? Power is energy per time, energy per time, energy consumed per time, which is equal to, what is the energy? Force multiplied by distance. That is work or that is energy. Force multiplied by distance by time. What is the unit? Force is a kilogram, that is mass into acceleration, meter per second square, into distance another meter, divided by another second. Therefore, power gets the unit kilogram meter square, second power minus 3. The dimension is m l square t power minus 3. So this is power. So these are all various dynamical variables by which the motion of a body can be defined. Look here, energy is a physical variable. Potential energy is mass, gravity into height. What is potential energy? The energy possessed by a body by virtue of its position. What is kinetic energy? Energy possessed by a body by virtue of its motion. So potential energy is mgh, mass m. What is g? Acceleration due to gravity. What is acceleration? Length per second square. And what is h? H is height. It is another length. So look at the dimension m l square t power minus 2. What is kinetic energy? Half mv square. The half you leave because it is not having any dimension. So what is m? M is mass. What is velocity? Velocity is length per time. So Lt power minus 1. It is given whole square. What is the dimension? M L square T power minus 2. So look at this action. Energy multiplied by time. That is joule second. What is energy? Momentum into length. That is M L T power minus 1 into length, which is equal to m l square t power minus 1. So into another t for another time. So you are getting m l square t power minus 1, which also has the same dimension as that of angular momentum. So that is why h is called a constant of action. So action, angular momentum, Planck's constant, they all have the same dimension. That is why h is called a constant of action. So under some limiting conditions, classical mechanical results can be obtained from quantum mechanical results. Hence, quantum mechanics is derived from classical mechanics. This can be explained by Bohr's correspondence theorem. Bohr's correspondence theorem is taught in detail in PG classes. So for UG classes, actually these dynamical variables themselves are not found in the syllabus, but in order to have a background for you to understand the quantum mechanics well, I'm just explaining all these things. Actually, these are all not found in your syllabus. Your syllabus directly goes to the failures of classical mechanics. Before knowing that what is mechanics and what are all the dynamical variables, you cannot discuss the failures of classical mechanics and all that. Therefore, I think with this we can stop the presentation and we can